Welcome everybody. My name is Daniel. I work for a company called Cloud66, and today I'm going to talk about containers. And I'm from Holland. The company is based in London, but I'm from Holland. And if you ever visit Holland and you drive to the Rotterdam harbor, you find this art piece, which is this folded container. And this is how I felt lots of time working with containers the last 4 years. And so what I wanted to do today is tell you a little bit of a story, like a journey. I will take you on a journey about how to use containers and how show you the pros and cons here. So I'm a developer advocate, and so everybody has maybe different definitions of being a developer advocate. For me, it's a little bit splitting myself in two parts. So on your left side, my right side, left side, I'm working on a platform at Cloud66 where we have a container as a service platform. And so that's probably about, I think, 70% of my time I'm just a developer and working on that platform. The other 30%, I'm listening to the ecosystem. What's going on in the container world? What are our customers doing? How they're using containers in production? How can we learn from everybody, learn from you, and then turn that back into the product. So that's what a developer advocate does. And so today, I'm going to talk about a hero. Does everybody know who this is? Probably, if not, this is Frodo. He's the guy, he's a hobbit, and then he goes on an adventure. It takes like 3 movies, and then he finally comes to Mount Doom and throws a ring into the fire, and everybody's happy. But when he started, he was a nobody. So from nobody to hero, it's a kind of journey. And if you look at lots of like hero movies, you find this design pattern called the hero's journey. And what I'm going to show you today is when you are going to start with containers and use containers in your company, make a transformation, it's a hero's journey. So I found this small video of 2 minutes to tell you about the 12 steps in the hero's journey. And the funny thing is, if you know this hero journey and you go next to the movies, maybe you go to the movies this weekend and you go to a hero movie, you find this design pattern and like, oh wait, now he's finding the mentor. Now he's gonna go the ordeal. Now he's gonna fight this thing and come bring back and all this stuff. So sorry that I ruined your movie night if you know how this pattern works. So I hope this video everybody can hear it. So this is a 2-minute animation done by students from Animation Academy in Holland, and it shows you what the hero's journey is. So enjoy.
This is the Hollywood Guidebook for heroes. You will learn the secret truth behind most blockbuster movies. They basically all follow the same 12 steps, also known as the hero's journey. Every hero's story starts off with some sort of nobody living in an ordinary world. But by following the White Rabbit, he will get the call to adventure. At first, he can't be too eager. He must refuse the call. Running away from his destiny, he will stumble upon a mysterious old guy who will turn out to be his mentor. Now he's ready to cross the threshold. Where he's going, he doesn't need roads. Of course, he will be tested, and he might need to win the game to gain new allies and enemies. He must overcome his fear by entering the inmost cave. Here, he will face his supreme ordeal, which will change his life forever. After defeating some bad guy, he'll receive his well-deserved reward. And because he can, he will be flying the road back. But before realizing there's no place like home, our apprentice must resurrect as a new person. Eventually, our hero will return to where he started, but things will never be the same again. This is what we call the hero's journey.
So I couldn't do that better, explaining the hero's journey in 2 minutes, so I'm happy that I found this video. So what I'm going to do is I'm going to apply the hero's journey on this journey when you want to implement containers in your company. And I found this GIF animation of transformers. It's a little bit of a transformation in your company. It's same as when you learning to play an instrument. If you play a new music instrument, you pick up the instrument and you start playing, and the first couple of weeks you feel already like, okay, I can master this instrument because you go really quickly. But it's a road with ups and downs, so it takes some time. So if you look at this hero's journey, which has 12 stages, I will explain every stage when you go on this container journey. But basically, if you look at this diagram, you can see the ordinary IT world and the very special container world. And I divide it into 4 parts, which is understanding why you're doing things, then learning the things, executing, so make a proof of concept, bring it back, and of course integrate in your team. So let's get started. So first, the ordinary world. So the ordinary world is where you're all living in right now. It's your company, or so the ordinary IT world is just, you're scrumming your way, you're posting post-its, you're programming, solving IDs, all that stuff. That's the ordinary IT world. You're doing maybe agile, and maybe already starting new microservices, the ordinary IT world. And you're happy. And you get a call to adventure. A call to adventure can be something like, maybe a manager calls you and said, so Daniel, I went to this Codemotion conference in Rome, and there was this guy talking about containers. I think that's the shit. That's what we need. That's a call to adventure. You're like, oh, wait a sec. I heard all about things about containers. But you're like, well, hold a minute. That's the moment is refusal of the call. You're like, yeah, no, wait. I mean, I already have this deploy scripts. We have this service running. We don't need containers. Everything's fine. No. Containers are not secure. Containers, no, we don't need it. That's a refusal of call. You're like, no, I don't want to have change. Change, as a human, we always change is a little bit scary, right? So you have to embrace that change. And so, in this hero's journey, there's meeting the mentor, an old guy like me, or somebody else, saying, well, these containers are really awesome, because what you can do, blah, 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 and you're like, yeah, that sounds really great. So tell me, how can I get started? So that mentor will explain you something. So I'm going to explain you this Artichoke model I invented. Maybe I'm going to make lots of money writing a book about it, I don't know. But if you know the artichoke, the nice part of the artichoke is the heart. Now you have to peel all those leaves and you get the heart. So we follow the heart, what drives you. So if you look at this, what I call the Artichoke model, let's talk about developers. So as a developer, you like your IDE, your programming languages, all the things, your MacBook, whatnot, your big screen, everything that makes you a great developer. But if you look at, the heart of the developer is just, I just want to write, solving problems, write elegant code. On the other side, if you look at the operations guys, they love networking, big servers, and all that stuff, and, provisioning things. But if you look at the heart of an operations guy, you just want to make sure your application is up 24/7, right? So that's what the operations guy is. In the end, if you look at DevOps, you find in the middle the heart is something which you want to solve a problem together. But also, if you look at the business guys, you want to do the same thing. They just want to, being agile, respond to the market. Talking to the development guys, we need some new IDs. Can we deploy it? And the operations guy says, yeah, of course, we can, So everybody is looking at that middle. And also for people using your customers are using that system too. And they were like, yeah, we need this new feature. And they're like, well, I have this monolith application. We have a release cycle of 6 months. We can't do it. So then you're like, okay, so if we all agree how we can bring value to our customers, to the business, but also to the developer and operations, there has to be something in the middle. And that heart, I think, is containers. So, anybody still refusal the call? No? Great. So you see, if you look at this diagram, you see the ups and downs, right? So there will be on this path to running containers in production, you will be euphoric, maybe depressed sometimes, so it goes ups and downs. So let's continue. So In this hero's journey, you're still in the ordinary IT world. You're still sitting behind your desk. And this is the moment you're crossing the threshold. This is the moment where you dive into the very special container world. You're going to install Docker on your machine, maybe. So let's be clear with one thing. Containers are just isolating processes. And you can see the cats can see each other. So processes can talk with each other. So let's give them some names. So we have Mr. PHP, Big Gopher, Miss Java, Madam Ruby, RabbitMQ, Mr. Database, everything. And this is what I like, because you're not locked into one language. So if you're working with a team and you have some guy who's really good in Ruby, you can start using Ruby. Or maybe your machine learning needs Python, you use Python, and you can mix it up. And also consolidate all those processes on your infrastructure. So I found this video, and also the cats were jumping out of the containers in other containers. But it wasn't a good example, because that was breaking the security. So it's a loop now. And also, database is hiding a little bit there. There's still a cat. Running database in containers is a little bit sketchy, so beware of that. I'm a little bit opinionated about it, so if you want to discuss database in containers, we can discuss that after this presentation. So this makes sense, right? Containers is an isolated process. It's just that, that's it. So how does that work? So I'm not a system programmer, but there's some very, 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 very clever kernel stuff, which is all Linux. I mean, if you look at before Docker made containers popular, there was like Linux containers, which was really hard to set up. It was namespaces and all that stuff. So, but we have this very clever kernel stuff to make sure that things are isolated. So on top of that kernel, we have a container. And it's an isolated process. And you need to tell the blueprint of that container, which is basically an image. And a Docker file is basically the dominant format to tell how an image looks like. So what goes inside that image? So we start from base, which is basically your root file system. Without a base, you can't do anything. Well, you can. If you have like a compiled language, like Go, you can run it without a file system. You just run it as a separate process. But just say we go from base, so you can say I start with Node or Ruby or Python. So you start with a base image. Then you run some updates. Maybe you install some packages. You set up the whole environment to compile your stuff. You copy your source code. Run to create your binary or whatever you want to run. Do some cleanups. And eventually tell how to run that code. And you can see here that it's filling up. So that's your image. So if you run a container, you get an image, boom, running. So this process, what I call is a containerization machine. It's basically a machine in your company bringing your code to production. This is what you need to master. So on top of it, you're bringing Ruby, and then it creates an image, or Java, or whatever, HTML5, I don't know why that's there, but yeah. So you're creating images, and great. This is something which I want to talk about. Think global, act local. It's so we have about 900 customers deploying Docker in production every day. We mentioned about 7,000 servers, and if people are picking up Docker, they're like, okay, I just write a Docker file and deploy it straight to production. But to understand containers, it's really good to start on your local machine, install Docker, and understand the power of containers before you can think about running it out global. I mean, of course, it's good to think about your production systems, but just start with your local machine. So you know a little bit of containers. This is the moment in the hero's journey when you meet your enemies, do some tests, make some friends. And so let's look about containerization machine again. So we put on all this code, but now we're putting in some shit. So containers and Docker won't solve bad programming habits or bad operations habits, because containerization is a collaboration between dev and ops. So if you put in shit, you get your nice image, but it's a little bit like this. Right? So if you're going to deploy this thing in production, probably this is happening. You can't polish it through it. You can't make it beautiful than it is. I mean, if it's shit, it's still shit in, shit out, right? So be careful. So this is what's happening. So when you start first with containers, you see the Dockerify is like, oh, this is just a definition of a VM. Let's put everything in a container. So you come up with this huge container. I didn't have time to create a slim image, so I created a fat one instead. But creating big images is creating a bigger attack surface. Shortcuts are evil, so make sure that you just get rid of everything you don't need. Less is more. So the approach is the moment where you're gonna, okay, so I understand Docker files, I understand containers. Let's make a little bit of a greenfield project just to show how things working. And so I give you some guidelines. So keep images, and the S stands for, let me say, so we're looking at this. So we have the big fat image on the left side, and we have this nice image for production on the right side. So let's start with slim. So there are 5 kisses here. So slim meaning get rid of everything you don't need. So start with a base image, which only contains the things you need. And of course, it's really easy to go to a public resource and just get like the base Python thing or the base Ruby, which has everything, but probably 80% you don't need. And also, you don't have control on the public images. So if you are going into production, it's really wise to create your own base images so that you know what's inside. It's a little bit of latency overhead, but it's important. Secure. So if you look at how containers are working, they're working with a layered file system. So if you're adding, for instance, secrets, it's a layer. You can remove that secret, but it's still there. So if something happening with your container, some hacker comes into your container or whatever system, they can hit your secrets. So make sure they are removed. And also, you're getting a base image, and maybe those base images have vulnerabilities. So make sure that you know what kind of vulnerabilities are in that base image. And if there are vulnerabilities, just update them. There's systems who can take care of that. Speedy. So as a programmer, of course you want to write performant code and put it in a container, but it's really good to understand, and that's something also a collaboration between developers and operations, is if I put my code in a container, then work together to find out how it performs, how much memory it's using, how much CPU, how much load it can take, and also understand what is needed in production. Stable. So things are changing. So if you look at Docker files, you can say, okay, I want to have this base image, which has the tag latest. So latest means you get always the latest. But what can happen is I run that on my machine, it works, pass it on to my colleague, and in that moment, latest changes and it breaks. So it's really important to create Docker files which are stable. So don't use latest. Make sure that everything is versioned. And set. Set is meaning it's immutable. And so you can have like creating an image which does a lot of dynamic stuff, like changing with environment variables and, okay, I have this container, it has to do a lot of things, and I don't want to update my container that often. But the nice thing about containers, you can just delete them and start again. So it's much easier just to create a new image. So make sure that it's set, that it's ready to go. So, in a hero's journey, this is the moment you're going to face, well, you're not going to face death, But this is the moment you're going to find out how can containers work in my company. This is the moment you can, come up, okay, which kind of, maybe you already have like projects you want to containerize, or you can start with a greenfield project, but this is the moment you're going to understand what's going on. And so now what? It's a little bit of a reality check. So you understand containers, you containerize some stuff, and you're like, oh man, this is great. But I'll show you how people are using containers at this moment. So if you read on Twitter, on the internet, everybody does microservices and everything, a container is microservices, all that stuff. It's not really true. Let's see. So 40% still are just containerizing a monolith application, just putting a PHP project or a Rails project in one big container and then scale up that container. It's fine, it's all part of the learning curve, because not everybody can start with a greenfield project. Then about 30% are doing like API-first approaches, where they split the front end and the API so that they can scale the API next to the front ends. And then you see about 20% who split the monolith. You can see like one big fat image and then smaller images already doing stuff. Maybe one image is running Ruby, the other one's already running some workers in Go and all that stuff. And about 10% are doing microservices. So if you heard a lot of microservices, yeah, that's the shit. We're not there yet, man. Take some time, so no worries. Then you go to the reward. And so you understand, again, containers, and now it's ready to go in production. But you understand what is needed. And running a container is one thing, maintaining is another one. So if this is your container running, you need a lot more around it. So you need some kind of platform. I call it a container nursery platform, because you have to keep that thing up, right? So this is more a little bit for the operation side. So you have to think about security. Not only the security of your container, but also the security of your servers, right? So it's still running somewhere on a server, which is maybe bare metal or in the cloud, but still you need to think about security. Data management. How do you handle data management? The whole thing about running databases in containers. How secure is that? What are you going to do with mounted volumes? How do you deal with backups or restores in containers? So you need to think about this. Orchestration. So what's happening when there's load? Is your platform scaling up things, scaling down things? Are there bringing up new nodes? Also life cycle. So probably you have like maybe a CI/CD in place, but you need to think about, okay, so how do I get the code from a developer, build an image, make sure that somebody signs off, and then bring it into production. Discovery, in the cat example, you see the cats looking to each other. It's called discovery, because you have like microservice, maybe one service wants to talk to the other one, so you're like, so where is service B? Oh, it's up there, I can talk with that. So that's called discovery. So you need to think about how discovery is going to work. Monitoring, especially when you have lots of containers, monitoring is going to be a big issue, because you've got a lot of logs. You need to analyze this, when there's something's happening, you need to react to it, scaling, and of course, scheduling. So, the road back. The road back is basically you're in this very special container world, and this is the moment where you're going to execute it. And also decide what kind of platform you want to run your containers on and all that stuff. So you need a little bit of headspace here. And what I'm trying to say with headspace is that the ecosystem is still changing a lot. For example, 2 years ago, everybody heard of Kubernetes, right? Now everything is Kubernetes. And like, oh no, we just implemented Docker Swarm or maybe missiles or created our own scheduler. Now it's Kubernetes. Where do I want to start with? Well, good bet is just bet on Kubernetes for now. But there's a lot of things going on. It's still maturing, that container ecosystem. So we are running those things already for 3 years in production. But still a lot of things are changing and people are learning. So it's really good to understand what your aim is. Well, maybe you're going to start with, I just want to use containers only for testing or only for development, not in production. So you need some other guidelines, of course, if you want to use it in a development test environment. But also in production, things are changing. And also, choose wisely. Maybe you don't need a big elephant. Maybe you don't need like a cluster of 5,000 servers. Maybe you can start small. So you have to be, choose wisely what kind of platform you're going to use. So in this hero's journey, you're leaving the very special container world and bring it back into the IT world. And that's where you integrate your learnings into your, IT world, which basically becomes the ordinary IT world again. So you bring the containers into your ordinary IT world, and then the next technology comes around and you start the cycle again. So these are the things I discussed today. So we have the hero's container journey. So in 12 steps with ups and downs, you learn new technology, implement it, and learn from it. Less is more. So still shit in, still shit out. So containers won't solve those problems. And it's really important when you're doing containers, make sure that you have a team, people working together, because it's a collaboration between business, developers, operations, and everybody. The Artichoke model, just think about it, the heart and the head space, and of course go for the slim images. So thank you for listening. I've got a promo code if you want to check out Cloud66. I also have like some swag here, stickers. Just take it if you want. So thank you. Any questions? Oh yeah, thank you. Was it a question? You want to? Yeah. Yeah, so the question is how you to deal with data management, with databases and all that stuff. So the funny thing is you go cloud native, where you spin up a whole environment every day with containers. All those containers are stateless. So what you're seeing right now, that people are using Kubernetes, most of the things in production, just to run the stateless containers. And the stateful container and databases are just running the normal way. That's what you see. There's a lot of companies trying to solve this problem, but I personally don't want to. I mean, we try to do this, but it's just too dangerous, to be honest, to run your database inside containers, especially when your containers grow. And also, the thing is, if you look at containers, there's an isolated process, and especially when you have big processes, they're going to call to memory locations. It still needs to be isolated. So if your code plays nicely with the memory management, you're fine. But I can see if you run like an RLAN process, sometimes it breaks out of the containers because it's doing some weird stuff with the kernel. So I'm a little bit opinion about it, but if you want to run database, I would say just run it the normal way, just to make sure, especially when you have like, enterprise databases, because there's a reason why we have database engineers, right? So, sorry, yeah. Yeah.
You have a favorite orchestrator for the container, have you?
A favorite orchestrator?
Yes, like Kubernetes or Docker Swarm or something else.
So yeah, so we built our own orchestrator in the last 3 years because there was no orchestrator. But we now moving to have our own orchestrator and Kubernetes. So now you can choose between our own orchestrator or Kubernetes. And Kubernetes is really an operations tool. We try to build developer tools around orchestrators, and still Kubernetes has a high learning curve, but it's a great technology. So so we're moving to Kubernetes. Yeah.
Thank you.
Any other questions? Oh yeah.
Virtual machines versus
Yes. So the question is, so what about virtual machines and containers, right? So basically, both are providing isolation. Yeah. Only the thing is, when you spin up a virtual machine, you have your Linux kernel, all the layers you need, and then your application. With containers, you just run, you have your kernel, which is already there. So spinning up containers goes quickly. You get more isolation on that thing. But yeah, it's an interesting discussion, of course. But there's differences, of course, in between VMs and containers. There's also a discussion going on if there's wise to run containers on VMs. So you have this group of people just saying no. Containers has to be run on bare metal because then you're not using any hypervisor anymore. And also there's now in the ecosystem, people are providing this thing when you take your container and just create a VM around it. So there's all these different technologies to still have like this isolation, but have the benefits of VMs. So it's still an ongoing decision. I don't have like an answer to it, but there are different use cases for it. Any other questions? No. So thank you for listening and have a good afternoon.